educational sales consultant with Hand2Mind. Uh, we are joined with Angie Meredith, also one of our, what's your new title now?
Consultant,
Still
educational
consultant?
consultant.
Okay.
We
I
get
just do
called all
sales.
kinds of things,
She
but-
teaches people. We're very similar. But she's going to walk us through Branding Camp today, and Ryan was kind enough to reach out and kind of help you guys out. I'm going to post the link again to Branding Camp in the chat in case not everybody has it. But without further ado, Angie, I'll let you take it away.
All right, great. Thanks, Nathan. And Ryan, did you need to welcome everyone? And
no, everyone, just welcome. And just a reminder, it is paid time right now. So I'll put the link to the time card information in the chat, and then you can do that towards the end. And yeah, we're ready to go.
Great. Thank you, Ryan. Thank you, Nathan. Well, welcome everybody. My name is Angie Meredith and I am with Hand2Mind. And you are here today to learn a little bit more about Branding Camp. So I'm not sure whether you've gotten your feet wet yet or not, but I know that Branding Camp is available to all of you on Clever. So easy to use, but if you haven't used it yet, we're gonna walk with you. Just a little background about me. I am a retired educator. I taught for 32 years here in the state of Georgia, and then I spent the last 6 years as an educational consultant with Hand2Mind, still in the educational field. So Hand2Mind, you might be familiar with us, you might not. So look at your math materials and see if maybe they came from Hand2Mind. You might see different names on it. Our name has changed over the last 50 years several times. We've been ETA, we've been ETA Cuisinaire, we've been ETA Hand2Mind. But one thing that hasn't changed is our philosophy. We do believe that children learn best by doing. And all of our materials are hands-on materials. We believe that children need to touch and feel those materials in order to learn. So without further ado, let's get into a little quote I usually like to start with. That one of the biggest challenges for teachers is trying to teach mathematics in ways they did not experience as students. And I know back when I was learning mathematics at the elementary level, it was all just books and paper. We didn't have manipulatives that we used, not that I was aware of. I don't remember using them. We memorized a lot, and it wasn't a lot of fun. And unfortunately, when we memorize things instead of actually understanding the mathematics, we tend to not remember that as well. And we also tend to have blocks later on in our brain as we learn deeper mathematics, or as we try to extend into harder mathematics in the high school and college level, that if all we've done is memorize and we didn't understand the way those numbers work together, then we have a mental block. So our goal is to work with teachers and work with students to learn conceptually, to learn using some hands-on materials so that when they get further in their mathematics studies, they don't get a roadblock. So it doesn't matter how you're learning, how your students are learning, whether they're face-to-face and you've got all your desks spread out, whether the kids are all at home learning, virtual learning, whatever. We have materials and we will be there to support you. So in the chat, what I'd like for you to put is, how will you be using math manipulatives when you're working remotely with your students this year? And I'm not sure how long you're going to be virtual, but as you're working with your students, tell me, how are you going to use math manipulatives as you're working remotely? What kind of manipulatives will you use? What are some of your favorites? What roadblocks do you have as far as using some of them? What kind of concepts do you like to teach with them? Put some of those things into the chat real quick for me. MathLink cubes. So I'm assuming you mean the linking cubes, connecting cubes. Good. So cubes. And Mrs. Castro and Bina, I think, would you make sure your chat is set to panelists and attendees? So down at the very bottom. Same with Raquel. Down at the very bottom, if you'll change it to panelists and attendees. Oh, Unifix cubes. Nice. Okay, 10 frames, counters, lots of 10 frames. Base 10 blocks, Unifix cubes, clocks, good. Oh, and they have them at home, nice. So they have theirs at home and then you can use your virtual manipulatives. Good, base 10 blocks. Good, 10 frames, number lines, base 10 blocks, Cuisinart rods, 100 boards, excellent. Okay, so we're going to look at some of those, and hopefully you'll get your colleagues and see how we can use it, because today we're going to be looking a little bit more closely at Brain Camp. So what I want you to do in the chat now is to put in, rate yourself. How familiar, how comfortable are you right now using Brain Camp? 0 if you've never used it, you haven't opened it yet. 5 if you've been using it a lot and you understand it. So anywhere from 0 to 5, kind of let us know your familiarity with it, your comfortableness with it. Okay, good. I have quite a range. Good. 0 to 5. And everywhere in between. Nice. Okay, good. So I'm going to go ahead and move over to Brain Camp. So this is what you see when you open up Brain Camp on your computer. And like we said, it's in your Clever. All you have to do is go down to the very bottom of your apps and just click it. You don't need your password. You don't need a password or username or anything. It's already set up for you. Okay, so I'm gonna kind of move my video because it kind of messes with the, there you go. There you go. So hopefully it will work better now. So as you open up Brain Camp, you're gonna see a screen that has 16 different manipulatives. Okay, anywhere from using your 10 frames, which are embedded within the color tiles, the linking cubes, the 2-color counters, to the Rec and Rec, all the way up to algebra tiles. So even if you have a child at home who needs some help seeing the mathematics, maybe you're a 1st grade teacher, but you've got a middle schooler at home and they're working on solving equations, then you might want to pull out the algebra tile. So you can use these at home as well as at school. Your students have full access to it as well. Okay, so most of these work very similarly. So I'm gonna just click on one of them just to kind of see, just to give you an overview of how they work. So I clicked on color tiles. And apparently my internet is going to be a little slow right now. There we go. Okay, so as you pull up any manipulative, you're going to see this with you so you can kind of see. If you look over to the far left, these first 2 icons will take you back to the home page where it showed all 16 of those manipulatives. So I can either click on the little Brain Camp guy, or I can click on apps and it will take me back to the original 16 apps. There's also a tutorial. Now this is very nice. Let's say you're not familiar with one of the manipulatives, but you really want to learn a little bit more about it. You can click on the video of that particular manipulative. We've also got some teaching ideas. Let's say there's something you're going to teach and you're not quite sure which manipulative would be best for that. There's some teaching ideas, so you can click on that and get them. This share button is something we are going to be using tonight. And so I do want you to be familiar with it. So we're going to be practicing it. This is something that you can use with your students you can design some pre-made screens with some questions on it or some problems on it that you want them to solve, a task or an activity. And then you can send that out to them as an assignment. And when they put that code in, they'll bring your assignment up. They can do the assignment and then they can send it back to you. So we're going to be practicing that tonight. So if you've never used that, you'll get an aha moment tonight. So in this tan strip, it's a tray, you'll see the manipulatives. So this particular one is the color tiles. So these are the 4 colors that you'll see when you're working with color tiles. Color tiles are just 1-inch square shapes that you can do a lot with. Then as I go along the bottom, see this looks like tic-tac-toe there? It puts a grid in the background. Some of the manipulatives have some sort of a grid where you can change this large map. This is your work area. So we try to make it as large as possible to kind of showcase. Is something that's called counts. So if you want to visually count what's out on your screen, you can press this and it will tell you have 2 red cubes out, or 2 red tiles out. Okay. We don't always use that. Over here to the far right are some tools. Okay, so this is a sorting circle for this particular one. So I can actually, change the size of it. I can put some tiles out and I can have the kids sort it. Or I can put a number in there and ask them to put a certain amount in there. I can put an addition or subtraction problem in there and have them move tiles over there to model it. Also down at the bottom is a tin frame. And I can easily drag tiles over, quickly fill. I also have an open array. So I can make it different sizes by just pulling that corner. Okay. And I have a text box. So if I want to put something, if I don't want to write it, I want to type it, I can do this and drag it anywhere on the screen. Maybe I want to put it here and have the students model something in between. I do also have markers. I can click the marker and change the color. I can do blue. I can change how large I want the pinpoint to be. And then I can write. Okay. I have a highlighter as well that I can change colors. And I can change the point size. I have an eraser. This eraser is only going to erase what I've written with the marker or the highlighter. If I just want to erase a few things, I'll just use my eraser. If I've written a lot of things on this board and I want to erase it all at once, I can just click Clear Drawings. If I want to clear my entire screen, down here, I just click Clear All. So that's just kind of a basic overview. I'm going to go back to the main screen. One other thing I want to point out on the main screen is that we have a share code area. So this is where when we are going to share our screen, share our ideas with others, this is where we put the code and click go, and then those screens will come up. And that will make a little bit more sense to you once we do it. Okay, so questions just about the basic overview, throw those into the chat. But it looks like we have a lot of beginners, but what I want you to do is dive in. So as we're working, just dive in and try it with us, okay? Because just like when you're learning to drive, The only way that you can learn to drive is to actually get in the car and go drive, okay? If you're learning to ski, the best way to learn to ski is to actually put some skis on and do it. So the best way to learn about Braining Camp is to actually get into Braining Camp and try it. You're not going to hurt it, okay? You're not going to damage it in any way. Just try it. And if it doesn't work the way you thought it would work, try something else, okay? So what I do want to let you know is there are a lot of benefits to using virtual manipulatives, okay? Of course, it is best that we use virtual manipulatives alongside our physical manipulatives, but that may or may not be possible in our teaching situations today. So know that your virtual manipulatives, you do have an endless supply, so you don't have to count out, you know, where you might have color tiles and you might only have 25 per student. You've got an endless supply per student. We don't have to clean them. We don't have to sanitize them. That's already done, okay? And research has shown that using these learning materials can improve attitudes towards learning mathematics. Kids get excited about using these materials and learning new things, okay? So let's dive right in. Let's try one. I do want to make sure that I said with that share feature, that is a workable page. What it will do is take a picture of what your screen looks like at that moment, and you can share that with students, and different students can be working on that page, and it's not going to affect what other students are doing. And then they can share that back with you. And you can make these pre-made screens. They don't expire. So you can actually get together with your colleagues and work collaboratively to develop some sets of codes for each one of your units that you're doing. And I'll share with you tonight so you kind of see where I've made some pre-made screens for tonight. Okay, you ready? Let's dive in. The first thing I'm going to open up to is a Rec and Rick. So I want to know in the chat how familiar you are with using a Rec and Rick. And normally you'll see 2 rows. There are different size Rec and Rics. So as you're putting that in the chat, same 0 to 5, how familiar are you with a Rec and Rick? And I'm going to show you a physical Rec and Rick. I'm going to put my video back on real quick. This is what a Rec and Rick would look like. Okay. Oh, good. We have a lot of people who are familiar with them. Good. There are larger Rec and Ricks as well. There are Rec and Ricks that have as many as 100 beads on them. I also have a Rec and Rick behind me that is 120 bead. So this is really good with working with addition and subtraction, especially with our second graders. Okay, it looks like we have quite a range too. We either have people who are very, very familiar with it or people who are not familiar at all. So let's take a look at this Rec and Rick. And let's just look at some of the basics about it before we do anything, okay? You'll notice that the Rec and Rick that I'm using and the Rec and Rick that I would use with first and second graders has 2 rows. And each of those rows has 10 beads. So I see 5 red beads and 5 white beads on each row. We push the beads over to the right before we get started. What we read are the beads over to the left. So this particular Rec and Rick would show the number 4. Okay. And what we're working on with kids is the idea of subitizing. So we don't want them counting one by one. We want to move them past that counting stage. And we want to get them into what we call subitizing, where they visually know how many. Just like when you roll a dice or when kids roll a dice, they don't normally have to count each particular pip, is what we call them. They don't have to count each one. They know visually what that number is. It's the same thing with the reckon Rick. So for example, if I push this over, I would want kids to say that that is 6. And I would want them to tell me why they know that that's 6. And they would say, I see 5 and 1 more. Okay. I would want them to do it not one by one, not 1, 2, 3, 4, 5, 6. I would want to say, show me 6, and this is what they should do in one push. Now they could have shown me 6 by putting 3 and 3, because we know we work a lot with doubles. And they would say, I know that that's 6 because 3, I know my doubles, and 3 and 3 is 6. So we move over the red beads first and then the white beads. There are a total of 20 beads on this particular reckon Rick. Okay, so let's get started. I'm going to do a number string with you. And I'm not sure whether your district, whether you use a lot of number strings, but number strings are kind of a systematic way of helping students learn particular strategies. So we want them to learn strategies, not just memorize facts and things like that. We want them to learn strategies so that they can become efficient and fluent in their mathematics. So number strings are normally a series of 5 problems that build on each other, okay? And it teaches a particular strategy. So I'm gonna do a number string with you. So humor me just a little bit and tell me in the chat, I'm gonna show you a reckon Rick. I'm gonna show you a number. I want you to tell me not only how many beads there are, but how did you see them? That part is important. So here's the first problem. Oh, got a runaway bead. How many do you see and how do you see them? Pop that in the chat. How many do you see? How do you see them? Good. So almost all of you said, I see 10. I see 5 on the top, 5 on the bottom. Okay. Here's the second problem. And doubles. Yes, we want them to talk about doubles. Tell me what you see here. How many do you see? How do you see them? Nice. So some of you said, well, I see 5 and 4, and I know that that's 9. But some of you said, I see 9 because this was 10, and it's 1 less than that. So 5 and 5 minus 1. Okay, so doubles minus 1. What do you see? How do you see it? Good. So I see double. I see 4 and 4, which is 8. Here's the fourth problem. What do you see and how do you see it? Good. So I see 4 and 3, which I know is 7. We just did doubles, 8 minus 1. Good. So each one of those built on each other. Here's the fifth problem. What do you see and how do you see it? Good. You see that 10 and 1 more, or you see double 5s and 1 more. Good. So that number string was a first grade number string, and it helps build the idea of doubles, helps kids to see those doubles, helps them relate it to a 10 frame. That's correct. Good. Okay, so let's look at what a second grade using doubles might look like. So now try this problem. What do you see and how do you see it? And number strings are normally a quick 10-minute routine at the beginning of a math lesson, at the beginning of a math session. Good. I see 8 and 8, which is 16. And Nathan, I see someone has raised their hand. Can you grab that? Okay, good. And how did you see that 16? Good, I see 10, 3, and 3. So some of you saw that 10 and then you saw the doubles again. Some of you said, well, you know what? We know our doubles. I know that 8 and 8 is 16. Good. So that's the first problem. What about this? What do you see and how do you see it? And this is a 8. Good. You see 8 and 7, and this is a harder addition fact for a lot of kids, but when they see it visually like this, it makes a whole lot more sense. So we just did 8 and 8, which was 16. This is one less. Some of you said I saw the 10 and 5 more. Good. Okay. Let's try the third problem. What is that? How many do you see and how do you see it? Good, you see your doubles. Double 7 is 14. Some of you saw the 10 and 4. Nice. Okay, so what about our fourth problem? What do you see and how do you see it? Good. 1 less than 14. Good. Some of you said, I see the 10 and 3 more. Good. Some of you said, I saw the double 6s and 1 more. So not everyone is going to see it the same. Okay, try this one. What do you see and how do you see it? Good. Most of you saw that 10 and 3 more. Nice. So 8 and 5 is 13. So like I said, number strings are normally 5 problems, quick 10 minutes before your math lesson, just to get kids subitizing and get kids thinking mathematically and thinking about math fluency and efficiency. Okay, that was using the actual strategy of doubles, using our Reck and Rick. Now we're going to try a different strategy. This strategy is called use 10 and adjust. So let's look at what that might look like. So I've built the number 13, and I want to know, how do I figure out 13 minus 10? How do I figure out 13 minus 10? What should I do? Take away that whole top row. So that's easy. So 13 minus 10, I could just move over the whole 10 and I'm left with 3. Okay, how would I do this? I have 13 still, but this time I want to take away 9. What should I do? I want to take away 9. 13 minus 9. What should I do? The most efficient method. Okay. Okay, so I could move over. Most of you are saying I could move over all but one, and then I'm left with one. If we're working on using 10 and adjust, we want them to think about the fact that 9 is 1 less than 10. So I actually could move over this whole row of 10 and move 1 back over. Okay, so let me show you that one again. So if I want to subtract 9, I can subtract 10 and add 1 more. So let's try that same concept again. So here I have because we know our kids have difficulty subtracting 9. So here I have 16 and I want to take away 10. How do I do that? (16 minus 10). Good, I just moved 10 over and I'm left with 6. Okay, so you know what my next question is going to be. So how would I do 16 minus 9? Excellent. Yes. So just like we did before, if I want to subtract 9, I can take the whole 10 away and move 1 more on the bottom, and I'm left with 7. Okay, let's try 1 more. I now have 15. And I want to take away 9. What should I do? Perfect. You got it. The same. I'm going to take away 10 and add 1 more. Okay. So it's a really good strategy to work with kids on subtracting 9 because they're comfortable subtracting 10, but subtracting 9 kind of makes them nervous, kind of makes us nervous too. Okay, so that's called use 10 and adjust. That was a first grade number string for later on in the year. Let's try a second grade use 10 and adjust. So take a look at this. I have 13. Okay. So how do we see them? How do we know that that's 13 without counting them all? Good. 10 on the bottom, 3 on the top. Okay, so that's 13. So 3 plus 10 is 13. So what is 3 plus 9? And how do you know? Good. So 3 plus 9 is like 3 plus 10, but I need to take 1 away. Okay, good. So it's just got this 1 that's less. I knew that 3 plus 10 was 13. 3 plus 9 is 1 less, so it's 12. What is 5 plus 10? And how do you know? Good. We know that one. That one's easy. 5 plus 10 is 15. So what is 5 plus 9? And how do you know? Good. So it's like 5 plus 10, but one less. Good. Thank you for explaining that part too, because that's the part we want to make sure we bring out with the kids. I knew that 5 plus 10 was 15. So 5 plus 9 is one less. So it's 14. So what is 7 plus 9? And how do you know? Good. So we know that 7 plus 10 is 17. So this is one less. So good. All right. So that's using the Reckon Rick. And we did use the Reckon Rick for some number strings, visual adding and subtracting to help kids with their facts. Okay. So that was, any questions on using a Reckon Rick? Takes just a little bit of practice. I think every first and second grade classroom should have these. I think it's a very important manipulative and very visual. Yes, Sandy, that is true. So when adding 9, our tens digit is always the 1 and the ones digit is one less. This helps them visualize why that digit is one less than that number added. We want them to see it. Good. Just a couple of things on the Reckon Rick board that we didn't use today, but you might use it at another time. So there is, because we read what's on the left, we can put up a screen over the numbers that are over the beads that are on the right. And I can either put up like a translucent one where they can kind of see through it some, or I can put up a solid one. And I can ask them, what's hidden on the other side? Plus, sometimes it just keeps them from getting distracted over what's behind it. Again, I can change the number of rows. I can go all the way up to 10 rows. Notice with the 10 rows, you do move over the red first, normally, but once you hit past 50, once you hit 60, the white beads will be first. That's kind of a visual for subitizing as well with larger numbers. Okay. I can also put in what's called a count. So when I bring it over, it will now tell me that I've got 5. I'm bringing over 2 more. And as soon as I connect them, it will tell me that I have 7. I can also put the bars in between so that I can kind of keep track like a number line. Okay. We'll go back to 2 rows. Okay. So questions about using a Reckon Rick? Do we feel more comfortable using one? I think it's a very powerful tool for first and second grade. Okay. All right. Well, I'm going to go back to the main screen then. Okay. And the next manipulative I'm going to look at is a 100 board. I think 100 board should be in every classroom. Every classroom. It helps kids see the pattern, building kind of a mental model of our number system. It helps them build that framework for base 10. It helps them explore some different patterns. And it develops some flexible and fluent computational strategies for 2-digit addition and subtraction. So as you're looking at your 100 board, I want you just to spend a few minutes looking for some patterns. And I don't mean patterns like I see the ones in the ones place right under the one. See the threes in the 10 in the ones place. Across, I see the 2 in the tens place. I want a little bit more patterns that you see. So if you can see some patterns, let me know. Do you see any patterns on our screen? So while you're looking for patterns, let me throw this out as well. It's really important as kids are exposed to math manipulatives, if they're not used to them, that you give them some exploration time, that you give them some time to explore that particular manipulative. Just like we did with the Reckon Rick, if you were not familiar with it, you would need some time exploring it and figuring out how that works. So it's the same thing with the hundreds chart. I want you to look, do you see any patterns to this hundreds chart besides the obvious ones that we always mention, where the ones are in the ones place all down this column? I see a 1 in all these ones places. So yes, the decade numbers are to the far right. Okay, those are powerful numbers. What other kind of patterns do you see? Everybody's studying them. Do you see any cool patterns? Oh, double numbers make a diagonal. Let me look at those. So 11, 22, 33, 44. Yes. Look at those doubles. Okay. We see every number one row below is plus 10. So if I started with 25, 35 would be 10 more, 45, 55, 65. Okay. Going down the columns, the tens place goes 0, 1, 2, 3, 0, 1. So the tens place, even though all the fours are the same, 1, 2, 3, 4, it counts up. When you look diagonally from the decade numbers, the numbers equal the decade. Ooh. So here's my decade is 10. 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. Look at that. Now, does that only work with the decade numbers? Could I start with another number and go diagonally? Will it add up to that? Now, it worked with 10, but if I start with 40 and I add 4 plus 9, that doesn't add up. But I like this. Going diagonally, it adds up to 10. Could I start with another number and go diagonally? Could I start with 5? What's going to happen when I go diagonally? Will it add up to 5? 1 plus 4. Oh, it does. We'll try another color. Somebody said start with 9. 1 plus 8, 2 plus 7. Oh, look at there. It does. So it works that way going this way. What if I try to go diagonally the other way? What kind of patterns will I see? Odds. So let's look. I have a 3. What happens when I go here? Here, here, here. They don't add up to 3. But what happens? Ah, the difference between those two numbers is 3. 4 minus 1, 5. Does that work with all of them? Yes, and it is an odd even pattern as well. Good. So there's tons of tons and tons of patterns. That's just one, a few of the different patterns. There's also a whole lot more. And I think when you leave this up, a hundreds board up in your room, your kids will constantly be looking at it and studying it and getting visual, and they'll come up with some new patterns. Okay. So yes, those are the multiplication for 9 as I go diagonally. I wonder why that is. Why, when I go diagonally, do I get multiplication facts for 9? Yes, because it's 10 minus 1. 10 minus 1. Excellent. Okay, so another thing that somebody mentioned was skip counting. So we can see patterns on our hundreds chart as we learn skip counting. So I can start counting by 2s. And what's going to happen when I get down to the next row? Excuse me. So I'm skip counting by 2s. What's going to happen? It stays in the same column. So I'm going to see that all of those are even numbers as I go. And it's easy for kids to see skip counting. Now, what if I try to skip count by 3s? 3, 6, 9. What's going to happen now? First of all, what will kids automatically do? So kids will think, oh, it must be going straight down like it did with the 2s, but let's try it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, uh-oh. So as I continue, it still forms a pattern, but it looks a little different. And it forms that diagonal pattern, right? But that's cool for kids to be able to see that diagonal pattern. What happens when I skip count by 5s? Because that's something that we want our kids to do. When I skip count by 5s, what will I see? I will only see these 2 columns, which as soon as you practice this and they see this, they have no trouble skip counting by 5s after that. Once they see that it's always in this column and always in this column. So there's lots of cool patterns that you can do. Lots of cool things with skip counting. So let's look at it though now. Let's use our hundreds chart for addition and subtraction. So I'm going to give you a problem to solve. And when we're first working with double digits, we're going to work with decades. We're going to work with multiples of 10. So let's say I want to do 47 plus 30. How would I model that on my hundreds chart? How would you model 47 plus 30 on a hundreds chart? Where would you start? And somebody said something a little bit earlier when we were talking about patterns. Good. So somebody said they would start at 47 and they would add 10, 10, 20, 30. So that's pretty easy. What if I wanted to work a problem that wasn't a multiple of 10 and I wanted to try 57 plus 22? How would I model that? 57 plus 22. Good. So I would start at 57. I would add 10, 20, and then I would need to go over 2 and add 2 more. So it's 79. How about this time I want 2 different ways. How would I add 35 plus 18? $35 plus 18. Okay. So I'm going to start at 35. So I have a couple of ways that people have mentioned. I want to add 18. So several people have said 18 is pretty close to 20. So they would add 20, and then they would go back to. Okay, is there another way? $35 plus 18. So we said we could think of 18 as being pretty close to 20. It's 2 away from 20. But could we just do 35 and add 10 and then 1, 2, 3, 4, 5, 6, 7, 8? Certainly. Okay. Which way was more efficient though? It was more efficient to think of 18 as 20 and counting back 2. Okay. Good. So let's look at subtraction then. So if I'm doing subtraction and I do 65 minus 20, how do I do that? Good, I need to go backwards. So I could start at 65 and I could go back 10 and back 20. Okay. How about 88? Sorry for my handwriting, minus 33. $88 minus 33. Okay, so somebody said start at 88. Sorry. Start at 88. Go back 3. I'm sorry, 3 tens, back 30, and then back 3 more. Okay. Is there another way to solve that? So as we're thinking about subtraction, we need to be thinking about, yes, very good. So somebody said start at 33. When we're looking at subtraction, subtraction is just the difference between 2 numbers. So I could start at the 33 And I could count to the 88. So I need to go down. I'm trying to get to 88. So I'm to 83 so far. Now I can count over to 88. And so far it took me 10, 20, 30, 40, 50, 51, 52, 53, 54, 55. So I can think of subtraction as addition. So I can think of finding the difference between the two. And for a lot of children, counting up is easier than counting back. Okay, so try to use that strategy as you solve this next problem. How would you do 76 minus 39? And I want you to think of more than one way that you can solve it. 76 minus 39. Think of more than one way. $76 minus 39. Oh, good, Clara. Clara said, make friendlier numbers. She took 1 from the 76 and she added it. All right, let's think about that for a minute though. That's kind of what we do for addition. But for subtraction is the difference between two numbers. So if, I need you to visualize this for just a minute. If this is 76, well, let me show you, hang on. Let me show you on an open number line. Okay, so if I'm trying to figure out the difference between 76 and 39, here's 39 on my number line. And here's 76. Yes, Clara, that's right. So if I want to make them easier numbers, because I really like 40, I'm going to make this 39 a 40. You just change the space between these numbers. And to keep, we had this space right here. Oh, sorry. So I've got this space. That's what my answer is. You changed the 39 to a 40. So you made the space smaller. To keep that space the same, I'm going to have to change that 76 to a 77. I'm going to have to increase it by 1. Now the space between 40 and 77 is the same as the space between 76 and 39. Does that make sense? So let me go back to my 100 board. And we had 76 minus 39. And Clara said, I like 40 better. So she increased 39 by 1, so she also needs to increase 77. Now watch. I can start at 77, and I can go back 10, 20, 30, 40. Nice. Okay, anybody do it differently? Did anybody start with 39? And count up to 76. 10, 20, 30, 31, 32, 33, 34, 35, 36. Sorry, 39. 70, 39, and 76. So I need one more. Okay, so 10, 20, 30, 31, 32, 33, 34, 35, 36, 37. So lots of ways that we can solve that problem. Very visual using the hundreds chart, and the more children work with the numbers on the hundreds chart with addition and subtraction, the easier it will become. Okay, I can also do missing numbers. So for example, I can put some numbers into my chart, but not all of the numbers. And then I can say, what number goes here? Where my cursor is. What number goes there? And why? How do you know? Might make a guess. Are you guys playing on your 100 chart? Good. 2 down. Good. So starting at the 25, 10, 20. I'm counting by tens. Or you could have started at the 43, 44, 45. So this is a really good activity too for kids to think about how they're going to figure out what a number is. Okay, so try one more. What number goes right here? And how do you know? Good, 74. And they said 65 plus 10 more is 75, minus 1 is 74. Nice. Okay, I'm going to clear that out. And we're going to go back to the home screen. Okay, we're going to now look at Cuisenaire rods. And when we look at Cuisenaire rods, now we're going to be sharing our screen to share some ideas that we have with Cuisenaire rods. How familiar are you with Cuisenaire rods? I love them. I use them from kindergarten up through middle school. I use them for ratio and proportion in middle school, but I'll turn around and use them for addition and subtraction in elementary. So people are not that familiar with them. Okay, let me show these to you. And then let's try some activities with them. I'm going to put a grid in the background. Cuisenaire rods have been around since about the 40s, 1940s. They were developed by Mr. Cuisenaire. And each of the rods, they're proportional. They go up by 1 centimeter. Notice I'm putting them on a grid. This is a 1 centimeter grid. And each rod is 1 centimeter longer than the previous rod. They are color coded. They go all the way from 1 centimeter all the way up to 10 centimeters. Now this gray one is not an actual Cuisenaire rod that you would see. This is just one that you only use virtually, so that if you want to use a number greater than 10, you can adjust it to whatever you need. Okay. Now I can adjust my screen. Look at you, Heidi, remembering all the colors. Because I will tell you, most children will remember the colors and the links faster than most adults, okay? Which is why I like to put it on a centimeter grid, so they can actually count how many squares, so they know how long they are. They are great with fractions, yes, for 3rd grade. But for 1st and 2nd grade, we're going to be using these for addition. So what I want you to do is I want you to pull over a rod, and let's pull over the yellow rod. The yellow rod is equal to 5. And I will tell you that down here, I can put numbers on them if I want to, but I don't usually, because they don't see them on the regular Cuisinart rods. So here's my 5 rod. What I want you to do is I want you to, yes, we can use them for comparison. These are great for comparison. Longer, shorter, that's correct. Okay, so I've got my 5 rod, and I'm going to try to make what we call 2 color trains. So I want 2 rods that when I put them together will be the same length as my yellow. What 2 rods can you put together to be the same length as the yellow? Okay, somebody said purple and white. Let's try it. Yep. So that purple has a length of 4, and the white has a length of 1. And that definitely makes my 5. What else can I do? Oh, green and red. So there is a light green and a dark green. Okay, and that is 3 and 2. Okay, what else? Any other combinations that I can make? Now, I could do 5 whites, but remember, we just want 2 rods. We only want 2 rods right now. Oh, I could do red and then green. So although I have the same numbers, I've got them in a different order. So I now have 2 plus 3. Yes. Yes, these are also great for tape diagrams, Isabel. Yes. Okay, so I could do the white and then the purple. That's correct. Okay, so this one would be a 1 plus a 4. So what I want you to do is I want you to pick one of the other rods. This is a great way, Ryan, to see commutative property, because this looks different than this, although they equal the same thing. Yes. We could also do a pretty colorful thing for associative property as well. Okay, so what I want you to do is I want you to pick a rod, either green, black, brown, blue, or orange, and I want you to set it up like we did here. And I want you to do the different addition fact families that you can for that particular rod. And when you do it, I want you to click share. And once you've set it up and you click share, this is what you'll see. You'll see this orange linker code. You'll see copy image and download image. What I want you to do is click link or code, and it generates a code for you. I want you to click this share. I want you to go over to the chat, and I want you to copy it in. Now, if I were to take this, oh, I'm sorry, I did it privately, sorry. There we go. So I now have it in the chat, so I can copy this. I can go back to the main page. I can put down here under share code, I can copy it. And exactly what I had on my screen will pop up. So you don't have to do the whole fact family before you share, just to kind of give you practice sharing. So again, whatever you have on your screen, click share. It will say link or code, click link or code, and then copy this code over to the chat. Okay, so for example, Sarah has a code in the chat. So I'm going to put her code down here and we're going to see Sarah's screen come up. Look at Sarah's. So she did the orange and she did use the number line down at the bottom, which is something I didn't mention. Thank you, Sarah, for mentioning that. And she's got all of her number combinations for 10. Okay, let's look at Vanessa's. Vanessa did 8. I'm sorry, 9. So she's got 8 plus 1, 7 plus 2, and all of her different combinations for that. Nice. Let's look at, oh, we are popping them in fast. Let's look at Jones. Ooh, okay, so Joan did 8 as well. And look at all her number combinations. Sandy, the share button is over here to the far left. So if you have something on your screen, click share and it's going to give you a code. So let us know if you don't find it. Let's look at Raquel's. Nice. So she also started with 10. Okay, nice. Okay, Dolores. Remember I said you don't have to have all of the number combinations in. We're just practicing using the share code. So however much you can get in there, that'd be great. Nice. So she did the dark green. And look at all of her number combinations. Let's look at another one. Nice. Okay. Yes. Oh, very good. Good question, Jean. So Jean is saying when students view our shared code, can they add to it or is it view only? They can add to it. So for example, I brought up somebody else's that they shared with me, right? I can move. I can make comments. Nice. If they forgot one, they can add to it. Okay. Yes. Sandy, if you're going to give something to your kids, you can download it or you can use the link, either one. Depends on how you're going to assign it. Ryan has put some directions in on your main page for some ideas for how to share those. Okay. And yes, when they add to it, they can get their own unique copy and then they can generate a new code and send it back to you. There you go, look. Okay, they've got the number line. They use the 9, the blue, which was 9, and have their addition facts here as well. Okay, let's do something a little different. I'm going to show you where I have a code, previously made form that I made, a workable page, a pre-made screen, and it's a puzzle. So I want to show you how I made it ahead of time. I just put it in Google Docs. So I made the screen ahead of time, and then I can just copy the code. Okay, so I'm going to give you a puzzle to solve using Cuisenaire rods. So you have to try to do what we call a mystery train. So for example, a train could be blue, light green, red. This could be a train. So it's got several of the rods connected together. So I'm going to give you some clues about what my train might look like. And I want to see if you can figure it out and if there's more than one solution to it and if you can share it with us. Are you ready? Okay. So the first one I'm going to give you is this one. So all I'm doing is I made a code ahead of time. I'm going to share it with you. Oh, and apparently I didn't copy the whole thing. There we go. Okay, so here's my clue. This train is as long as an orange rod. The shortest car is red. Hang on, let me send this code to you so you can actually bring it up as well. The shortest car is red and there are fewer than 4 cars. So what do you think my train looks like? And is there more than one solution? So I put the code into the chat box. It's the ZV3U7 code. It already has where I wrote out the puzzle. And I want you to try to solve that puzzle. Then do share code and send it back to us and let's see if you got it. And let's see if there's more than one solution. So all I know so far is my train is as long as an orange rod. So Sarah thinks she's got it. Let's look. So when I copy Sarah's code, when I copy her code, you notice that she's got my puzzle up here. She's got the words up there, okay? So she says that it is 1 red rod, 1 yellow rod, 1 green rod. Did anybody get something different? So that works. The shortest car is red and there's fewer than 4 cars. Let's see what Vanessa got. So she got red, yellow, green. She got red, yellow, green. Let's see what Tony has. Uh-oh. Tony won't let me read your code. Let's try Laura's. I'm not sure. She's got yellow, green, red. Did somebody get a different solution? Is there another solution? She's got just red and brown. Shortest car is red and 2 is fewer than 4. Nice. Okay, let's see what Bridget has. Ooh, these are coming in fast. That's good. Red, yellow, green. So far we've got 2 different solutions. We had red and brown and then red, yellow, green. Red, yellow, green. Good. Okay, and you had both. Is there another one? Oh, somebody said red, dark green, red. So 2 reds and a dark green. So I'm just going to put that one on this one. So we said somebody had red with brown. Somebody else said red, dark green, red. Good. Red, purple, purple. Good. Nice. So you got 4 different solutions. So sometimes there'll only be one solution. Sometimes there will be more than one solution. Let's try one more puzzle. So I'm going to go back to my codes and give you another one. You're right. We couldn't use white because our riddle said that red was going to be the shortest one. Okay, now this one says this train is as long as a blue rod. Exactly 2 of the rods are the same color, and the train has 4 cars. What will this one look like? The train is as long as a blue rod, so I know it's this long. Exactly 2 of the rods are the same color, so I can't have more than 2 rods the same color. And I can't have 2 rods of one color and 2 rods of another color. Okay. What can I do? The train has 4 cars. Anybody have a solution for this one? Oh, I didn't put in the code. I'm sorry. So that you don't have to retype or look back at this one. So there's the code for this one. It's a P8L. So somebody says light green times 2, a red one, and a white one. So this has exactly 2 are green and 4 cars. Perfect. Perfect. Any other solutions? Is there another way I could look at it? It's the P8LFK. Let's see what Lauren has. Okay, so she's got 2 reds, a white, and a purple. Perfect. So these are called mystery trains. You just give kids clues. It kind of gives them a chance to explore with their Cuisenaire rods. And it gives them a chance to look at different clues and try. Some of them will have just one solution. Some will have more than one solution. Okay, I'm going to go back to here. Can we see all the students work at the same time? Not at the same time, no. But what they can do is you can assign something, Laura. You can give a problem or something for them to solve. And maybe you're not doing it. Maybe it's a homework assignment. And they can go in, pull that up, do their assignment, and then they can send that back to you. They can download, so that you can put it in a Google Doc. You can put in their pictures. So there's several ways that you can save it. And I think that Ryan has some great resources for you on the website. So Sandy, I believe Ryan also has information about that, about how they send those assignments back to you through your your account, through your Clever account, where your Google Classroom, where you assign things and then they can download their images, or they can download their actual picture to it. Okay. So questions about manipulative use, questions about, and of course I had other things planned, and we have run out of time. It just went so fast. You guys did a great job participating. So how was it? Did you learn some new things? So we didn't get to all of the things that were all of the manipulatives, obviously, because not all of them will be manipulatives that you would use for first and second graders. But what I want you to do is, as you're exploring with Braining Camp, is I want you just to think about what kind of concepts you want to teach. Google it up and look to see how people have done that particular skill using manipulatives, and then try it with your Braining Camp. Play with the Braining Camp just like you want the kids to play with manipulatives. Play with it, see what it does. You're not gonna mess it up, you're not gonna hurt it. And if it didn't work the way you wanted to, try something else. Yeah, can we have a part 2? I'm sure we can set that up. Part 2 is a great idea. So sometimes that's a good idea, maybe later on in the year when you've got different concepts, or when you're more comfortable, to kind of expand and get into some different concepts. Okay, you guys did a great job. Yay. Any questions specific to Braining Camp, or even specific to some of the manipulatives that we use? Maybe you weren't as familiar with some of them as you'd like to be. So questions, and somebody had something in the Q&A. It looks like you got it, didn't you? Either Nathan or Ryan got that. Okay. All right. I'm going to put Nathan's contact information up. Nathan is your person. He is your sales consultant for your area. So any questions that you have regarding Braining Camp, regarding manipulatives, whatever, Nathan can help you. There's his contact, his email and phone number.
I will always be happy to help.
Okay. So thank you guys. So Ryan, I think you kind of answered questions as you went along as well. You've got some links in there. So that's awesome.
All right, well, nobody, oh, hold on, something's popping up. All right. If nobody has any questions, we can wrap this up.
Okay.
Well, thank you everybody for joining us today. I know you had a long day teaching already.
I know, oh my goodness.